And we're live.
Good morning, good afternoon, good evening, wherever you are on this planet, and welcome to our SETI Live. So today we have a special SETI Live with two citizen astronomers who are going to talk to her about the fantastic discovery they made using the Unistellar EV scope. Hey, hi, Rachel, how are you?
Hey, nice to see you.
Hi, Brad, how are you?
Oh, I'm doing great.
All right, where
Thanks
are
for
you
having
located,
us.
both of you? Where are you?
California.
Okay, you're both in California. So I'll remind our viewers that we are going to have a conversation describing basically what discovery is all about. And of course, you can send us comments, questions by using the stream we have on YouTube, Facebook, Periscope, Twitch, etc. So welcome. So today we are going to talk about asteroids. And I want to mention first as an introduction that asteroids are very numerous in our solar system. We know roughly 1 million of them at the moment. And when I say at the moment, it's because there is hundreds of telescopes which are observing the sky almost continuously now. And they basically sometimes see those tiny dots moving around. And quickly we catalog them and realize that those are asteroids. So we have asteroids which has been discovered mostly in the main belt between the orbit of Mars and Jupiter. That's where most of them are now. We have some asteroids which come very close to us called the near-Earth asteroids. And then we have asteroids which are much more distant, and some of them are icy asteroids, icy bodies like comet, but also trans-Neptunian object, Kuiper belt object, centaurs, Trojans. There is a million of names for each of the asteroids, but that's not what we're going to talk about today. We are going to talk about specifically asteroids in the main belt, specifically two of them, the asteroid Moskva and the asteroid Begonia. So before entering into the story of the asteroid, I should mention that we don't know much about asteroids. Most of them, the million of them we know, we have an idea of the position because we have seen them. From the brightness, from the color, from the magnitude, the brightness, we derive the shape, the size, and sometimes we can derive the shape, but using what we call Likert. I'm going to describe that in more details later on. The reason we are interested as scientists about asteroids is because asteroids are what we think the remnant of the formation of the planet. So if you want to know how planets form, well, what we want to do is to study the bricks, and the bricks are those remnant asteroids in the main belt and elsewhere. So Rachel and Brad, you are what we call citizen astronomers. That's the name. So I hope you have a badge now. See, or you're going to add that in your resume, right? So tell us, citizen astronomers of the Unistellar Network, what it is and what is Unistellar and what is the EV scope? I have one behind me here. So maybe one of you want to talk about the involvement in the Kickstarter.
Yeah, sure. I'll do that. So I think I was backer 868. So I don't know if that's soon or not, but I saw the telescope on Kickstarter, and it seemed like a very approachable way for me to get more involved in astronomy and to really flourish. And where was I going to say? I just wanted to get involved in telescope, in looking through telescopes and seeing what space is all about.
Okay.
Yeah.
So you had a telescope before?
No.
No?
Well, when I was a kid,
Okay.
but this was the first time we have a real telescope here.
All right.
Yeah.
So Rachel, you basically jump also with the Kickstarter. You basically participated to the Kickstarter campaign of Unistellar in 2017. You mute.
There we go. And about 3 years later, we ended up, we got the Kickstarter in January of this year. So we received the telescope. which was perfect timing for the quarantine environment that we all kind of exist in now. So it's become kind of one of our big hobbies. We can kind of spend nights and look at the stars, and it's very nice socially distancing activity that we can do and hopefully contribute a little bit to the scientific community.
All right. So the Unistellar Network is a network of 3,000 telescopes. I can share my screen and maybe show a map here. We have a map that's also visible on our on the press release published by the SETI Institute. So let me just share this. This is the map of the location of the EVscope users at the moment. So you may probably one of these dots here in California somewhere.
Yes.
So with this telescope, which is a digital telescope, you can basically observe the dark sky, but also participate to scientific investigation, as you mentioned. So tell us what happened in August exactly. The one who remember how this story started.
Yeah, so I follow Unistellar on a lot of social media, and I saw kind of on the Twitter you put out we want you to look at this during this time period. And so we took out the telescope to the backyard, thankfully had a really nice clear sky, no fires, no wind. And we were able to get a 5.5-hour observation of one of the targets. And it ended up getting a pretty good curve. We submitted our log, and I think we received kind of word that we had a really good curve within a week. So it was really exciting kind of email to get during this time.
So what did you do during this time, Brad? You were staying in front of the telescope, or you?
Yeah, it was both of us together. So we would go out and stare up, try to see what the telescope is seeing, just tracking it in general. We worked together to make sure our logs were accurate, and it was a team effort.
All right. So what did you see in the eyepiece or on the screen of the phone?
So over time, we actually got to see the asteroid, just a little line that grew a little bit after each observation.
Yeah, because so what happened is that the telescope stay at the same field of view and stabilize itself, stay over there, looking more the same field of view, correcting for the rotation of the sky due to the rotation of Earth and the motion, etc. So what happened, the telescope stacks images using the stars as the background as a reference. So what you see over time when you observe an asteroid is a line becoming bigger and bigger as the asteroid moves with respect to the background stars. So then you send us the data. That's the process that we are improving. And on our side at the SETI Institute and Unistellar, we receive the data from all of you. So for this specific asteroid, we receive observation from 7 observers from countries like 4 countries. So it was Finland, in the United States, in France, and in Switzerland. People observe at almost at the same time than you, the same week, in fact, the asteroid, and send us the data. So the data we receive are not these pictures that you see. The data we receive is individual frames taken by the telescope every 4 seconds approximately. So let me go through the techniques here. So from these frames, we identify the asteroid itself, and we compare the brightness of the asteroid with respect to the brightness of stars surrounding it. So over time, we see a small variation of the brightness of the asteroid. And the reason for which the asteroid is not, the brightness of the asteroid is not regular is because the asteroid, which is here, for instance, is not perfectly spherical. It's not a sphere. It's irregular in shape. So let's assume it rotates on itself like this. I don't know if you see well here, but you basically see a variation of brightness due to the apparent surface, we call, of the asteroid itself. So that's this tiny line that we sent you. I may have it here, if it's on the press release. So you can see this small variation of light. And what is very interesting here is that that was one of the first time we derived what we call a lie curve of an asteroid with those observations that you sent us. So thank you.
Awesome.
This was an amazing moment for us. And I can say there was a lot of smiles at the office at the SETI Institute and at Unistellar when we saw the first lie curve of an asteroid. Thanks to you, Data.
Fantastic. Very exciting to receive.
So now you are a citizen astronomer per se. So what do we do with this lie curve? Without entering in too much details, what we do, we combine those observations coming from all those observers. We have multiple lie curves. And from those lie curves, and this is done with my colleagues at the Charles University Institute of Astronomy, Joseph Dürer and Joseph Dürer and Joseph Anush. And what they managed to do is to create a 3D shape of the asteroid that you can see here. And that's the spin of the asteroid too, and the 3D shape. And what is interesting here is that we have observation of this asteroid, which has been taken in the mid-infrared. So it's another wavelength range for which the flux, the brightness is directly proportional to the surface. So what we did, we look at the observation at the time of, we look at the shape of the asteroid at the time of the observation in the mid-infrared, and that allows us to also derive an estimate of the size of the asteroid. Now we know that Moskva 787, which is located in the main belt, has a size which is between 25 and 30 kilometers. So that's the first scientific result of the Unistellar Network in the field of small solar system bodies. So thank you. It's not much, it's one measurement, but that's the beginning. And as I mentioned, we have 3,000 EV scopes at the moment on this planet. So we can imagine that we're gonna get more lie curves, and with those lie curves, we're gonna get more size measurement of asteroids and be able to get more scientific information about them. So you are going to receive one of those, by the way. I was supposed to send it to you. It's gonna be slightly bigger. We're gonna get one of them pretty soon as a token of appreciation for your efforts and for your work on this scientific project.
Awesome. Thank you.
So before I continue, I would like to mention that we have people watching us right now from, oh my God, a lot of countries: Liverpool, Norway, Ohio, Portugal, California, San Diego, Brazil, England, Virginia, Skopje, North Macedonia, Canada, Japan, Montreal, Minnesota, Germany, Serbia, Macedonia, North Carolina, Sydney in Australia, Oklahoma, New Jersey, Vancouver, Michigan, Texas, Duluth, I don't know where is that, Netherlands, yes. Anyway, welcome. Thank you for watching us, and thank you for being part of this conversation. So today we are talking about the Unistellar Network and the first scientific observations with Rachel and Brad, who were the first citizen astronomer who observed the asteroid 787 Moskva. So what is the next step for you guys? Are you now you have this first badge of citizen astronomers, the first significant discovery. Are you continuing to observe for the Unistellar Network?
Yeah, the second you put out a kind of a Twitter alert, we'll put the telescope in the backyard, assuming it's clear.
All right. What kind of view you have in the backyard? 360 degrees, or you just see narrow windows? What?
It's 360. It's a 360 on most days, yeah.
Yeah. Yeah, I go on my roof sometimes when I want a full 360 because I have the house of my neighbors, but my house is slightly bigger. So we see a of people observing sometimes. It's fun. Go ahead, Brad.
We have a hill that blocks a part of the sky, but for the most part, it's clear, assuming there's no fires.
Yes, that's the thing. The weather, the fires, there is all those limitations, of course. So we have different scientific projects with the Unistellar Network. This one was a pilot test that we did to show that we can derive the lie curve of an asteroid. I will mention that, I don't know, have you participating to any of those so-called occultation events?
We've done a few. They happen pretty early in the morning sometimes, so it's been hard to get them.
Let me show a bit what is an occultation event then. So an occultation event, it's a way for us to derive the shape of an asteroid and also confirm its shape, derive the size of an asteroid and also confirm its shape. So what we do in this case, we don't observe directly the asteroid. We observe the star and we wait for the asteroid to pass between us and the star. That's why we call that an occultation. And for a few people located on the specific area on Earth called the band of visibility, they will basically see the star disappearing for a few seconds. So what we see on Earth is the shadow of the asteroid. So the interesting part here is that if you have multiple observers located at different locations, you basically can have a timing which is slightly different depending of the shape of the asteroid. So here, for instance, we have an occultation observed from New York and from Arizona of two unistellar eviscope users of the asteroid Begonia, which is another main belt asteroid located in the main belt. So it's interesting because we didn't have a very good idea of the shape of this asteroid and even less of the size of the asteroid. There is like two models, and one of the models seems to fit better the other one. So now we have derived that that's the shape of the asteroid, and we have an estimate size of 83 kilometers in this case. So this one is bigger than the asteroid Moskva that you observe. So this is a kind of observation we want to be able to do on a regular basis, like once a day. It allows us to see the shape of the asteroid, to see the location of the asteroid very accurately as well, and also to see the surrounding of the asteroid. You probably know that asteroids have also moons and rings. So with this kind of event, we could detect the moon or we could detect the ring around the asteroid. And that's one of the things we would like to do with the Unistellar Network in the future. So I encourage you, if viewers here who have an eviscope, and you, of course, Rachel and Brad, if you get an alert about an occultation passing above your house at a specific time and it's nice, try. It's fun. For this one, if you look in the eyepiece, you will basically see the star disappearing for a few seconds. Okay, but then the data analysis is interesting. Sorry, go ahead, Brad.
All right, just was saying that we'll have to try that out.
Yeah, so this is the first science, the second type of science we do with asteroid. We do planetary defense as well. We have the campaign for 1999 AP10, which is running at the moment. That's to derive the shape of a potentially hazardous asteroid. We can also do detection of transiting exoplanets. So I'm sure you're gonna try that pretty soon. We have a team here at the SETI Institute working with the Unistellar Network, and the goal is to be able to send you alerts at a specific time when we have an exoplanet detected by TESS, the NASA spacecraft, and we want you to help confirming this existence. So this is something that you are going to receive regularly through by email or by Slack, and soon on the app. You will be able to see when there is a new target to observe. Transit exoplanets can last up to 7-10 hours. So that's possible. We're gonna ask to have a combination of observer between the East Coast and the West Coast to be able to cover the entire period of the transit. We're getting a lot of questions. I'm gonna start with the questions for you guys. The question I get is about the Bennu. Can we see the Bennu asteroid? So Bennu is the NASA target, which has been for which the spacecraft took a sample recently. So to my knowledge, Bennu is too faint for the Unistellar Eviscope. We advertise the telescope by being able to observe up to magnitude 16, but in fact, we now know that it can observe up to magnitude 18 in dark sky. So you know the Bortle of your the Bortle class of your site, Richard, Brad? No? So that's basically a way to measure the quality of your sky based on the brightness. So typically, A bottle 2-3 is very good, is a countryside. Bottle 7-8 is what you get in the middle of a city.
Okay.
So
We're in the-
suburb is a between, and it depends, of course, of the type, size of the city. If you have an ocean nearby, the bottle class varies based on that. So I don't think Bennu is observable with the EV scope, but we may try by combining multiple observations from multiple telescopes. So do the asteroid move as the do the telescope move as the asteroid is in motion? You want to answer to this question?
So it tracks the asteroid. So we'll start it in one position in the sky,
Yeah.
come back and check it 2 hours later, and it's pointing it to a different part of the sky.
Exactly. So it's basically capable of following the sky. So it moves to be able to track the object. Yeah. Do you do any search for large NEOs type asteroids? Okay, so that's an answer. That's a question for me specifically. We do not do search per se of NEOs at the moment, meaning that we don't ask people to randomly observe the sky. So we hope to find an asteroid in their field of view. The reason for which we don't do that is because it's kind of a very tedious research, and there is a lot of space. There is a lot of ground-based telescopes who are doing that very well, such as Atlas, Pan-STARRS, and soon LSST. However, every time people observe, they can send us the data if they want of their observations. So in the future, we will probably have a very complex algorithm that will search into the database and do comparison of bright sources to detect potential transient events, such as a supernovae, the presence of an asteroid or a comet, or maybe even the detection of an extraterrestrial civilization, which is sending us laser, telling us that they are here by sending us a laser beacon. This may happen. We are working on this database at the moment, so it may happen that soon discoveries will be made by simply using UEV scopes to observe the sky. I just remind that people can ask more questions. We have a few more minutes. We have 5 more minutes. So Brad, before we finish, and Brad and Rachel. So when you, are you scientists, first of all? That's something I should have asked at the beginning. Are you astronomers?
So we're both in the biotech industry. We have a science background, but not an astronomer.
You're not astronomers. We have a science background. So you do you write codes? Do you do stuff like that, or? So
I work a lot with data and write algorithms and that sort of deal.
Okay.
Yeah. And
I'm more on the finance side, but I appreciate a good data collection because clean data makes my life a lot easier in work, and I assume for you guys as well.
All right. So right now the data we send, in the future you will have an account, and I know that a lot of I see already a question about that. If you have an EV scope, you will have an account, and you will be able in the future to access to your data that you collect as well, to do your own data analysis. We are working with community colleges, high schools, to basically allow to have the EV scope as part of the program for astronomy. So this way they can use the EV scope to do some research, to explore the dark sky, to see galaxies, comets, nebulae, do some of the observation that we mentioned, these scientific alerts, but they can also do their own observation if they want to test a photometric algorithm, they want to collect data to derive the astrometry, the accurate position of a star. They will be able to do that by getting the data themselves on the EV scope. So this is a work in progress. And of course, as you probably know, Rachel and Brad, we're a small company. We started with 2 or 3 years ago only, and now the software is improving, the database is improving. So that's the goal. So SETI Institute is the scientific partner of this Unistellar EV scope network. And the reason for which SETI is a partner is because at the SETI Institute, we do believe that outreach and education is an important part of science. And we have, we basically, as a scientific institution, we'll be able to curate and promote some of the scientific campaign with the EV scope. SETI is a search for extraterrestrial intelligence. So as I already mentioned that briefly. One of the reasons the EV scope is interesting for the SETI Institute is also to be able to have a network that is capable of observing the sky 24/7. Imagine what we could do in the future when this EV scope will be everywhere on this planet. We'll be able to basically, from my house, request for observation if there is something happening in the sky. And if you have space telescopes, you know that there is a lot of stuff happening in the sky. Gamma ray burst, gravitational waves, new comet discovery, and often we need to have a quick confirmation of this discovery. So this network will be able to tell us that. These networks will be able to allow scientists like me to be able to see the sky almost 24/7, thanks to the contribution of citizen astronomers. Oh, now we have more questions. So we have a questions about 2008 JL3. If you're gonna hit the Earth in 2027, I don't think so. I will check and I will answer to you on the YouTube if you post the comments at the bottom. I will take the time to answer to your question. Another question we have about the EV scope. I have an EV scope and I would like to be informed on asteroids occultation. How do I get notified on those? So there is multiple ways to do that. The simpler way is to write an email to the Unistellar Network. So you're a Unistellar group. So you write citizen science at unistellaroptics.com. We will write this down as well in the description of this video. You can also follow us on Twitter, Facebook, and Instagram. We post some of the alert as well. That's the way you found out about this, right? The first time.
Yep.
And also we have a Slack. We have a special Slack for scientists. Are you part of this Slack, Rachel and Brad?
Not yet, but I will.
Not yet? Okay.
So
that's a great way to meet other citizen astronomers to discuss together about new data or to coordinate data. We have now observers that coordinate the data. We had an astronomers professor at Oregon University who observed an asteroid and asked to have an observation taken simultaneously from far away. And someone in Chicago observed it. And what they saw is a parallax effect. Because the asteroid is closer to us compared to the star, if you observe with two stations separated by thousands of kilometers, you'll be able to see a small relative motion on the image. And by measuring the relative motion and knowing the distance between the two stations, you will know the distance of the asteroid. So we have people doing this on Slack. So I encourage you to join us on Slack. I know it's another social media, but it's it's a fun one, and you can talk about more than just astronomy. You can talk about your passion for astronomy or what you like to do. And there is very nice people on this Slack, and I really love to see every morning the conversation happening there. And I think that's all. We're just sharp 30 minutes, so it's perfect. One final words for you, Brian and Rachel. If you have anything you want to share, tell us. I have a question. I have thousands of questions. I know you want to continue to do citizen science, but what is the most exciting for you at the moment with this, in this world? Not only about astronomy, but
well, I know for one that I can't wait to have access to the data itself from the telescopes. I want to apply some algorithms to it and see what I can find.
Okay. And you, Rachel?
I get very excited kind of when we get the results and we can kind of see the image and see something happening. And then when we finally get the results and knowing that we kind of contribute.
Very good. Well, I'm super happy to have you part of the network. I think it's very important we bring back astronomy, especially in this difficult time where people are home and the news are not very positive. It's sometimes great to look outside and using a telescope, you see more than you can see with naked eyes. And there is a lot of beauties in the sky. So we need to take the time to see them and to watch them. Okay. So thanks everybody again. Thank you to our viewers, wherever you are on this planet. If you like this video, please put a thumb up on YouTube. Subscribe to get the next videos. We are not only talking about EV scopes, we're talking about life on other planets, discovery of water on the moon. That's going to be the topic of the next SETI Live, next week. And thanks again, Brad and Rachel. Have a good evening, and see you soon for another big discovery, I hope.
Hope so. Thank you.
Bye-bye.
Bye.